Hello students, by this time all of you would be clear about the meaning and units of energy and determination of energy and physiological fuel value of foods covered in the last class. Now we are going to focus our attention on basal metabolism, which covers energy metabolism at rest. After completing this module, the students are able to understand the following objectives: meaning of basal metabolism, methods and procedure to find out BMR, and factors influencing BMR, that is basal metabolic rate. First, we shall briefly deal about the energy metabolism at rest, that is known as basal metabolism. Basal metabolism is the total amount of energy required to carry on the involuntary work of the body necessary to sustain life, including functional activities of the various organs such as brain, heart, liver, kidney and lungs, and secretory activities of the glands, peristaltic movement of gastrointestinal tract and oxidation process in resting cells, and also the maintenance of muscle tone and body temperature. In other words, the basal metabolism is the energy metabolism of the subject at a complete physical and mental rest, having normal body temperature and in post-absorptive state, that means 12 hours after the intake of last meal. The basal metabolism is the largest component of the average person's daily energy expenditure. It can be expressed in terms of BMR, that is basal metabolic rate. Basal metabolic rate is the rate at which the body uses energy to support its basal metabolism. The energy value of food is easily estimated by using the table of food composition or a computer or using various apparatus like bomb calorimeter. Like that, many ways are available to determine the energy needs of an individual, which is mainly based on energy output. To estimate the energy output, it is essential to compute the amount of three major components of energy expenditure. The two major components are: number one, energy metabolism at rest; the second one, energy metabolism during physical activities. Apart from these two components, third energy component is the body's metabolic response to food, that is, body speeded up metabolism in response to food. This category of energy expenditure is termed as thermic effect of food or diet induced thermogenesis. The two major ways in which the body spends energy are: number one is to fuel its basal metabolism and the second one is to fuel its voluntary activities. Basal metabolism generates energy to support body's work that goes on all the time without our conscious awareness. The basal metabolism consumes wonderingly large amount of fuel and varies person to person. People often want to know how they can speed up their metabolism to promote fat loss. It is not possible to speed up their BMR, but amplify the second component of energy expenditure, that is voluntary activities. Now we will see the methods used to find out BMR. The basal metabolism is measured under the following condition. Number one, the person should have post-absorptive state, that is 12 to 16 hours after the meal, usually performed in the morning. Second one is recycling and awake, that means 1.5 hours rest before the test is necessary if the person has any activity in the morning. Then third one is the person should relax and free from emotional upset of fear of the test itself. The next one is normal body temperature and free from any of the disease. The next one, comfortable room temperature and humidity of about 21 to 24 degrees Celsius and is in case of a female not during menstruation. Let us understand the different parts of the apparatus used to find out BMR. BMR is usually determined using the apparatus of Benedict and Roth respiration. This apparatus consists of bell type spirometer, Kymograph drum, and third one is mouthpiece with necessary attachment. Now we will see about bell type spirometer. The bell type spirometer is a hollow, double walled cylindrical vessel. In a narrow space between the two walls, fit a second inverted hollow cylindrical vessel or bell. This bell is counterfoised so that rides easily up or down in the angular space between the two walls. Inside this, there is a can containing soda lime for the absorption of carbon dioxide in the expelled air. This can has a hole at the bottom which is covered by a dish-shaped screen, and the tube carrying expired air is fitted into this. The angular space between the two walls contains water which acts as a seal. Now we will see the second part, that is Kymograph drum. This Kymograph drum will revolve or mount on the platform next to spirometer. This is the Kymograph used for recording oxygen consumption by fixing on the drum. The horizontal lines are calibrated in millimeter. The vertical lines indicate the time in minutes. On the other side of the paper, correction for temperature and pressure, body surface chart, the standard in kilocalories per square meter per hour for both male and female, and also computation formula are given. A small pen is attached to the spirometer bell rest on the Kymograph graph sheet to record the reading. There is a timer attached underneath the platform in such a way that when the timer is started, the Kymograph drum revolves, completes one vertical column on the sheet in 1 minute. The next one, third part, mouthpiece. This is the mouthpiece attached to the metallic piece, the other end of which is connected to the rubber tubes. One tube is connected to the spirometer through which oxygen is supplied to the subject undergoing the test. The other tube is attached to the can containing soda lime. Both the tubes work one way and are controlled by the flutter valves. The clinical thermometer is attached to the spirometer for recording the temperature. Now we will see the procedure to conduct the test. 2 liters of distilled water is poured into the outer fixed cylindrical of the spirometer. The spirometer is filled with oxygen to raise the spirometer bell. The sterilized mouthpiece attached to the tube. The next procedure is the room temperature and barometric pressure are noted before the start of the experiment. The subject is made to lie down quietly and familiarize with the mouthpiece by inserting in between the teeth and the lips. Nose clips also fixed and any leakage of air is checked. The subject is instructed to breathe slowly through the mouth. After a few minutes, when the subject's breathing becoming regular, the subject is connected to the apparatus by turning the knob attached to the metallic piece to which the tubes are carrying the gases are attached. The switch attached to the timer is turned on. The pen is allowed to rest on Kymograph sheet. During the test, the spirometer bell rise up and down with the respiration of the subject, and this is the traced on the sheet. This recording is continued for 6 minutes. At the end of 6th minute, the timer is stopped. The subject is disconnected from the apparatus. By recording the height and weight of the subject, the surface area of the subject is computed. From the temperature and pressure noted down, correction for this factor is determined using the table given on the sheet of the chymogram. Are you able to understand the procedure? Okay, now we will summarize the procedure involved in determination of basal metabolism. Basal metabolism is usually determined using the apparatus Benedict and Roth. This apparatus is a closed circuit system in which the subject breathes oxygen from a metal cylinder of 6 liter capacity, and carbon dioxide produced is absorbed by the soda lime present in the tower. Oxygen cylinder floats on water present in an outer tank. The subject wears a nose clip and breathes through the mouthpiece the oxygen present in the cylinder for a period of 6 minutes. The volume of oxygen used is recorded on a graph paper attached to it. Since the subject is in the post-absorptive state, RQ respiratory quotient is assumed to be 0.82 and calorific value of 1 liter of oxygen consumed is taken as 4.8 kilocalorie. Now we are going to see the procedure for evaluation of BMR. For example, if an adult man having 50 kilogram of body weight, he is consumed oxygen in 6 minutes is 1.1 liter during the test time. That means heat produced in 6 minutes is 4.8 into 1.1, that is 5.28 kilocalorie. The heat produced in 24 hours, that is 1 day, means we have to multiply this thing with 60. 5.28 into 60 into 24 and divided by 6. That means the calculation is 1267.2 kilocalorie of energy. So, the basal metabolism of an individual for 1 day or 24 hours is 1247 kilocalorie. Shall we pass on to the next method to determine BMR? Yes, the second one is closed circuit indirect calorimeter. This is a closed circuit system in which the subject receives oxygen only from a measured source of oxygen rich air and exhales into a container in which carbon dioxide and water are removed, while the remaining oxygen and nitrogen are recirculated. The amount of oxygen in the air mixture is measured before and after each standard 6 minutes test, allowing the amount of oxygen consumed to be determined. The use of 1 liter of oxygen under normal condition of temperature and procedure corresponds to the release of 4.82 of energy when RQ is 0.82 under basal condition. Thus, the kilocalories released during the consumption of any volume of oxygen can be readily calculated under these conditions. Now, we will see the next method, open circuit indirect calorimeter. In this method, normal room air is breathed in and exhaled carbon dioxide generated from it is calculated and measured. Knowing the amount of carbon dioxide produced in a given time allows the calculation of amount of oxygen consumed to generate that carbon dioxide, and thus the amount of energy released can be calculated. The open circuit indirect method is even less expensive than either direct calorimeter or closed circuit indirect calorimeter. It is also reduce the possibility of error as the result of the situation of metabolism caused by the use of oxygen-rich air in the closed circuit method. Now, we will see the determination of BMR by calculation. BMR can be calculated not only by direct and indirect calorimeter, but also by using formula. The first formula is by using body weight. For female, the weight in kilogram multiply with 0.9 kilocalorie into 24 hours. For male, the weight in kilogram into 1 kilocalorie into 24 hours. The second method is a Harris-Benedict equator. For female, 65.5 plus 9.56 into weight plus 1.85 into height minus 4.68 into A. A means surface area of the person. For male member, it is 66.5 plus 13.75 into weight plus 5 into height minus 6.75 into surface area. The third formula is using the metabolic body size. It is a standard one for both the sexes, 70 into weight in kilogram power of 3/4. Like that, number of methods are available to determine BMR. Now, we will note the factors influencing BMR. Some factors are responsible to increase BMR, some factors are responsible to reduce BMR. Now, we will see the first factor, surface area. The basal heat production and heat loss is directly proportional to skin surface area. For example, a tall thin person has a greater surface area than an individual of the same weight who is short and fat. The former therefore will have higher basal metabolism. About 80% of energy is from glucose and fat, which is lost as heat, 15% of the heat loss being from skin. The remaining heat loss occurs from the lungs and through the excreta. The more the surface area, the higher the BMR. A difference of weight of a 10 kg would account for a difference of around 500 kilojoules per day in BMR in an adult man and woman. The second factor is body composition. All the body tissues are metabolically active and being constantly maintained. Their components are degraded and resynthesized with an accompanying requirement of energy. Muscle, brain and various glands and organs such as liver are relatively more active and metabolically consume large amount of oxygen per unit of weight and produce more heat than the less active tissues. Bone tissue and adipose tissues are relatively, that is metabolically inactive and require less amount of oxygen per unit weight. The total basal energy requirement per unit of body weight is higher when the muscle tissue is in higher proportion to total body weight. Now, we will see the third factor, gender. The BMR of an adult man having 65 kilogram of body weight is around 1 megajoule per day, higher than a woman of having the same age and weight. Women have more adipose tissue and less muscle tissue compared to men of the same height and weight. Young adult male contains 14% of fat and young adult female contains 23 to 32% of fat. The BMR for women is 10 to 12% lower than that of men of the same age. After the age of 10 years, the female have lower BMR than male. In women, there is a premenstrual rise and post-menopause fall in BMR. And next factor is age. BMR is at its highest during the first 2 years of life. It declines gradually throughout childhood and accelerates in adolescent period. Thereafter, the decline continues throughout the life with an average about 2% per 10 years after the age of 21 years. The rapid growth rate explains the high metabolic rate in early childhood. Whenever there is a growth, there is an increase in BMR. In the later years, muscle tone decreases and there is a reduction in muscle mass and hence the BMR is low. Next factor is sleep. During the sleeping hours, the basal metabolism is about 10% lower than that of the waking state. It is also depends on the amount of motion during sleep of an individual. Next factor is body temperature. An elevation in body temperature above 37 degrees Celsius or 98.4 Fahrenheit increase the basal metabolism by 13% for each degree Celsius, 7% for each degree of Fahrenheit. Increase in chemical reaction increases the body temperature, hence the increase in BMR. The calorie requirement also increases during fever. Next factor is endocrine glands. The hormone thyroxine contains iodine is secreted by thyroid gland and is a powerful stimulator of metabolism. Deviation in basal metabolism of more than 20% from the normal predicted levels almost always indicate some problem in thyroid function. In hypothyroidism, BMR may be depressed as much as 30% as the result of under secretion of thyroxine. People with hypothyroidism have low total energy needs, so they gain weight easily. In hyperthyroidism, basal metabolism is elevated to 50 to 70% above the normal level due to over secretion of thyroxine. Another hormone is the growth hormone that also stimulates the new tissue formation and is responsible for the enhanced metabolism that is observed in children, infants and teenagers. An increased secretion of epinephrine during the excitement or fear or the temperature raise the metabolic rate. The disturbance in the pituitary gland may also modify the metabolic rate. Just prior to the onset of menstrual cycle, the metabolism increased slightly. Eighth factor is pregnancy. BMR increases by about 5% during the first and second trimester. During the last trimester, BMR increases by 12%. This increase can be accounted for the high rate of metabolites of the fetus, placenta and increased activity of the maternal tissue, thereby increase in weight of the mother. Next factor is state of nutrition. After prolonged calorie undernutrition, BMR may fall to at least 20 to 30% below normal. This reflects the body adaptive efforts to conserve energy when there is a deficiency. The Lux's consumption theory says that when a person takes more calorie than needed, the body tries to adapt using more calorie and thereby avoids deposition of fat. The BMR is affected by food consumption. Overfeeding increases BMR by 5 to 10%, while underfeeding reduces the BMR by similar amount under more dietary condition. Next one is environmental temperature. The lowest metabolic rate is observed at the environmental temperature of 26 degrees Celsius or 78 degrees Fahrenheit. Higher the metabolic rates are observed at temperature both above and below the figure. A sudden decrease in environmental temperature causes shivering and temporary process of heat production, with the result there is a increase in BMR. This adaptive response of the body to lower environmental temperature is called cold induced thermogenesis. The BMR is also increased at the temperature above 30 degrees Celsius due to energy cost of sweating. The next factor is smoking. Research indicates that the habitual smokers, when they stop smoking, have a tendency to gain weight. This may be caused by the fact that the nicotine increases BMR by 10%. The next factor is genetic difference. BMR varies by up to plus or minus 10% between the individuals of same age, sex, body weight and fat-free mass, and there is a growing evidence that some of this variation is determined by genetic factors. The next one is psychological state. The psychological states may affect energy expenditure, as acute anxiety is a prompt stimulant of the epinephrine secretion, and this increases energy expenditure. Next factor is pharmacological agent. Nicotine, caffeine increases energy expenditure by small but measurable amount. Beta blockers commonly used to treat hypertension may lead to a slight decrease in energy expenditure and hence a tendency to gain weight. Next factor is disease process. This may increase metabolic rate like in fever, tumor and burns to the skin. This mechanism by which these processes influence energy expenditure are likely to involve intracellular signaling agents such as cytokinins. Any one of you recall the various aspects of today's module? Yes, we have reviewed the basal metabolism and determination of energy metabolism using various methods and also using factors affecting BMR. By conclusion, you students are able to understand energy metabolism at rest and consider it as basal metabolism. This module also focused the various methods available to determine BMR and also factors related to BMR. Thank you, students.